Hi grade 9s, we're just going to finish up the unit with a couple more lessons here. So first one, 7.1b, it's angle properties of polygons, and at the very start we have a couple different parallel line situations, so let's just get going on those. The first one looks like this. So taking a look at the situation, we definitely have some C pattern, some Z pattern. We got a straight line. So let's just start with the straight line and solve for y. Solve for z. So taking a look at z, you have a straight line and 38 degrees. So any straight line is 180 degrees, and 180. So what we're talking about is right here. That's a straight line, and all the way across it, 180 degrees minus the 38 equals 142 degrees. So Z equals 142 degrees. So there's our first solution. Now, if we did a Z pattern, you got a Z pattern right here, down and here. So that makes this 38 degrees with the Z pattern. So again, 38 degrees, and that makes y have to equal 142. Because it's a straight line. So you have a straight line right there, and so you got another 142 degree. Now, last one. If we know y is 142, we got a straight line with x. Or you could look at it as F pattern. F pattern, underneath F and underneath F, x is 38 degrees. Many ways of solving that, but there's a couple of them using F pattern. We could have used a C pattern. 38 degrees and y is a C pattern. That has to add up to 180 degrees. And we could have got the solution that way as well. So, like I said, there's a few different ways of doing it. Neither of them are wrong, as long as you are able to come up with a solution. Okay. Drop my marker. Next one, we got a triangle and parallel lines. So let's break this down with a Z pattern. We've got the 65 coming to the Z. So that's got to be 65 degrees because of Z pattern. So now we have a Z pattern, 65 and a 65, and we have a specific type of triangle. It's isosceles, so we know that this is 65 as well. So that's a total of 130 degrees. So Z is the interior angle of a triangle. The three of them together has to add up to 180. So 180 minus the 130, Z is equal to 50 degrees. That's because this angle, and this angle are all interior angles of a triangle. They have to add up to 180 degrees. So we've done that one. We've got an x to figure out. Now the x is part of a straight line. So 180 minus 65 is 115. So that's the x, because it's a straight line. Has to add up to 180 degrees. And the last one, there's a couple different ways of doing it, but probably the easiest is it's another straight line. We got a 65, we've got Z at 50, and we've got Y. And all of them together has to add up to 180. So we know Y has to be 65 degrees. Straight line, 180 minus 65 minus 50 ends up being 65 degrees. Another way of looking at that could have been a Z pattern. So taking a look, you get the Z pattern there, down, there, 65 and a 65, and that would have been a Z pattern that would have worked as well. So a few different ways of solving that one as well, and both of them getting you to the finish line. A polygon is a two-dimensional enclosed figure with straight sides. Recall that the sum of the angles inside a triangle is 180 degrees. How can we use this information to determine the sum of the angles inside other polygons? So what we want to do is break down the shapes into small triangles. And you want to start with a single vertices and go from there. So let's do that right now. I'm going to show you what I'm talking about, and you can also reference page 389 in your textbook. It's going to have the exact same stuff. So page 389 in your textbook is going to help you fill in the chart, because I'm not going to fill it in entirely for you. You might need to Google a couple, but you can fill in that chart, and I'll show you how to get the sum of the interior angles. So first of all, your first shape was a triangle. And sides were 3. Number of triangles, you only have 1. And sum of the interior angles is 180 degrees. So your very first one, there's your triangle, 3 sides. It makes 1 triangle, and there's 180 degrees. Now, quadrilateral. Example of a quadrilateral. Okay, 4-sided, blank and blank. Here's where we're at. You've got a square or a quadrilateral, 4-sided. We need to figure out the number of triangles and then the interior angles. So taking a look at this thing, we start in one corner only, and we make lines to create triangles. So I've got 1, 2 triangles. So that is 2 triangles. And 2 of 180 degrees is 360 degrees. So there's where we're at. Now the next one, pentagon. Pentagon, 5-sided. So the easiest way to do this is 5-sided, and we still need, so 5-sided, but we still need to figure out how many triangles we can create. So taking a look here, if I started in this corner, I can't go to that corner, but I can go up here, create 1 triangle. I can create 2 triangles, 3 triangles. 1, 2, 3 triangles. So I've created 3 triangles this time. So that's 3 interior triangles. And the angles is going to be 180 times 3. So 180 times 3. And the general formula, so the generalized formula, if you know how many sides there are, it's n minus 2 times 100. Okay, what you didn't hear from the last one was that the generalized formula is n minus 2, where n is the number of sides. So n minus 2, where n is the number of sides, times 180 degrees. And that'll tell you how many degrees of interior angle there are in any given polygon. So that's going to help you fill in the chart. So you've got triangles, quadrilaterals, pentagons, goes all the way up to the n-sided polygon. And you've got a generalized a formula for all of that. And the generalized formula again, n minus 2, where n is the number of sides, times 180 degrees. So determine the sum of the interior angles in a polygon that is 5-sided. For 5-sided, 5 minus 2 is 3. 3 times 180 degrees. If it's 10-sided, 10 minus 2 is 8 times 180 degrees. 37-sided, 37 minus 2 times 180 degrees. 90-sided, 90 minus 2 times 180 degrees. So all you're doing is n minus 2 times 180 degrees for each of those. Now, the next part gets a little more tricky. How many sides would there be in a polygon with interior angles that add up to 2,880? So we'll do a couple of those examples as well, just to get you ready to go. So, see if I can find my marker. There it is. And the first one, 2,880, equals n minus 2 times 180 degrees. So 2,880 equals n minus 2 times 180 degrees. The very first step is you need to get an n by itself. You need to divide by 180 degrees. Divide by 180 degrees. Now, n minus 2 is equal to, and 2,880 divided by 180 degrees is 16. So the very first step, always divide by 180 degrees, and then you add 2. Add 2, and you get 18. So that's exactly what you're going to do for 6,840 and 4,140, etc. You divide by 180 degrees, and then you add 2. But really all you need to do is follow that formula. N minus 2 in brackets times 180 degrees equals the angles. Your homework is page 390, 1 to 5.